Every time I learn more about physics, I just see the world differently.
We teach you what we've learned over the last, a handful of centuries about how the universe works, what her rules are. The goal is more the process of how we learned that, how to approach these, physical problems we see in the world, and boil them down to little simple models that we can sort of handle, one at a time.
SU is a respected research university in terms of physics, and this means that they have collaborations with other universities in other countries. It means that SU is where I would develop my skills as a physicist, where I would be able to talk to other people just beyond the university, but collaborations with European or Asian universities, which is something that is happening in our research group.
The physics community at SU has a tremendous sense of forward momentum, to use a physics term, because everyone is really working on their own individual projects, yet we are collective as a campus community, as a department on campus, making sure that everyone feels welcome and feels like they have the tools that they need to succeed in their future research projects.
I've spent 4 years working with the Syracuse University Gravitational Wave Group in different capacities. So I spent 2 years working with Professor Peter Salson, and I was doing detector characterization for the Laser Interferometer Gravitational Wave Observatory. Shorthand is LIGO. Basically, there's this big international collaboration of scientists who work with these observatories, attempting to detect gravitational waves, which are signals from distant astrophysical objects like black holes and neutron stars. So detector characterization, which is what I was doing, is kind of studying problems that we have with noise in the detector and things that kind of get in the way of our attempts to measure gravitational waves.
As physicists, we're trained to have a lot of different tools in our tool belt to tackle a question. We have math, we have model systems that we've made really simplistic so that we can really understand how those work, and then we just apply different modifications and sort of build on those problems to tackle all different systems that we encounter.
I loved every physics class I've taken at SU, and all of the professors are so amazing and accessible and incredibly inspiring. But my favorite would have to be the first ever physics class I took, Physics 215 with Dr. Lisa Manning, because she's my biggest role model and inspiration, and she's my PI now for my research group.
All kinds of great stuff going on, many different opportunities for undergraduates to participate in the work that we do, kind of pushing forward on this boundary of knowledge that we're always trying to push back just a little bit further.
I feel like there was some sense of community, and I haven't felt that in other departments throughout the school, so that's what I liked about the physics department.
I think what's so unique about a physics degree is that when you're studying physics, you're learning material, you're learning about how the world works, but you're also learning a way of thinking and problem solving, which is something that people cite often makes physicists very employable, just makes you really good at a lot of different things.
SU Physics is just great. The staff is really supportive here, and I think you'll just have a lot of fun on your physics journey.
Professor Balmer was writing it out and explaining it to me, and I was understanding it, and I had this moment where I was like, wow, this is college, this is physics, I'm doing it. That was a defining moment in my physics career, because I really felt like I wasn't just planning on doing it anymore, I was actually doing it.